In this lesson, we'll focus on rotation. We're going to see how to convert angles from degrees to radians and also use a bit of trigonometry to distribute shapes around the circle.
Now let's turn our attention to our rotation angle here. This 0,3 is in radians, not in degrees. Radians might be confusing for some people. We can learn how to use them and get used to calculating things in radians, but it is usually more convenient to work with degrees. And it's actually very easy to convert between them. Say we wanted to rotate our square by 45 degrees. To get the equivalent in radians, we just need to divide it by 180 and multiply that by math.pi. This formula is quite handy, and we might want to use it again. We can convert it into a function, so we don't have to write the same thing multiple times. I'll call it deg2rad. It will take as a parameter an angle in degrees, and then return degrees divided by 180 and multiplied by pi. So now we can just use angles in degrees. With that in place, we can make our sketch a bit more interesting. First, let's make our shape smaller, like a very narrow rectangle. And what I want to do is to distribute this shape around a circle, like the hours on a clock. We need a variable for the number of copies of the shape. I'm going to call it num, and set it to 12. Then we need a for loop running 12 times, and put our drawing code inside it. Now we need to change the angle of rotation based on the index of the loop. If we imagine a pizza and we're cutting it in 12 slices, what is the angle of each slice? The pizza is a circle, so 360 degrees, divided by the number of slices. With some quick math, we can tell that this is going to be 30 degrees. But remember, we want this in radians, so we need to use our function to convert it. This is the size of the slice, and for the actual angle, we need another variable. Const angle is going to be slice times I. This is going to be 0, and then 30 degrees, and then 60 degrees, and so on. And then we need to use that in our context.rotate. And we get a little star shape. Now to place these strokes around the circle like a clock, we need a bit of trigonometry. Trigonometry is about the relationships between the sides and the angles of triangles. It's beyond the scope of this lesson to teach trigonometry, but we can quickly refresh our memory. Here's an animation to help. Here we see that the angle is increasing over time, and the cosine of that angle is going up and down in a fixed interval. The same goes for the sine of the angle, and we can see that there is an offset between sine and cosine. Both of them together describe a position around the circle for a given angle, and this is exactly what we need. So first of all, we need a new variable for the radius of our circle, which is going to be width times 0.3. And then, since we're going to have a different x and y for each shape, we can rename our existing x and y to cx and cy to be the center of our circle. And then we declare x and y again, this time with let, because we're going to modify their values inside the loop. And here's where we use sine and cosine. We're going to set x to the center of the circle, we'll see x, plus the radius of the circle multiplied by the sine of the angle. So math.sine, and in parentheses, angle. Then a similar expression for y with cy plus radius multiplied by the cosine of the angle. This is almost what we want. We just need the strokes to rotate the other way around, So we need the context to rotate to minus angle. And here's our clock. And we could change the number of slices to anything we want. I'm going to keep it at 12 for now. One thing you might have noticed is that we're adding cx and cy to x and y. We could also split that into two calls to translate. In this case, the final result doesn't change. I'm only showing it to you as an alternative, so you can see that there's a bit of flexibility here.
Now we covered rotations. In the next lesson, we'll look into scale and we'll also talk about utility functions.